Let's do an easy application of these inverse trigonometric functions. Let's suppose that we want to find an angle in this given triangle, theta, and we're given the length of two sides. We can use inverse trigonometric functions to determine what the angle is. The first step in doing this is we have to, if you will, tie together the pieces of information that we don't know and the piece of information that we do. So we don't know theta, and that's what our objective is to figure out, theta. However, we do know the side opposite and the side adjacent. So what trigonometric function ties together an angle, the opposite side, and the adjacent side? Well, that's tangent. And so I could write that tangent of theta is equal to the opposite, which is 7, divided by the adjacent, which is 5. Well, how does this help me determine what theta is? Well, if tan theta is 7 over 5, what would tan inverse of 7 over 5 be? Well, if you set that equal to theta and write what this means in terms of tangent, you would have exactly this expression here. Now you might be thinking to yourself, what about the domain restriction? Doesn't theta have to be between minus pi over 2 and pi over 2? And of course the answer is yes. So technically, if you wanted to write out what tan inverse of 7 over 5 is, you can set it equal to theta and write what this means in terms of the tangent function. So this means that 7/5 is tan theta, with theta between minus pi over 2 and pi over 2. However, when you're dealing with right triangles, this condition here is always going to be satisfied because the sum of the three angles in a triangle, let's call this one alpha, theta plus alpha plus pi over 2 has to be pi. Or in other words, theta plus alpha plus 90 degrees has to be 180 degrees, and so this theta here could never be larger than pi over 2. And it most certainly could never be smaller than minus pi over 2 because, well, theta would have to be bigger than or equal to 0 because it's the angle of a triangle. So when you have a triangle here and you use the inverse trigonometric functions, all of the domain restrictions will be satisfied because the angles, both of the angles which are not right angles, will have to be between minus pi over 2 and pi over 2. In fact, there's an even stronger condition on theta that for this triangle, theta has to be between 0 and pi over 2. And so the domain restrictions do not give you any issues when you're dealing with determining angles of triangles. So that was quite a long way to say that you don't need to worry about the domain restrictions when you're using inverse trigonometric functions on triangles. And so this angle theta is going to be tan inverse of 7/5. And now, while there will be problems that will require you to evaluate the inverse trigonometric functions by hand, you simply can't evaluate all of them by hand. And the reason why we can't evaluate this by hand is because, well, we don't know a theta on, or perhaps better said, we don't know a special theta like pi over 6, pi over 4, pi over 3, for which tan theta is 7/5. If this over here was 1, then we can find one of those special thetas for which tan theta is 1. But when you cannot, well, when you can't, you can't, and then you can go ahead and use a scientific calculator or a graphing calculator or whatever you are permitted and have available to you at the time. When you do use your calculator, make sure that you're in the mode that you would like to be in. In this problem, I think I'll answer it in degrees, and this ends up being 54.46 degrees, rounding to the second decimal place. Okay, so we wrote a trigonometric function which involves the pieces of information that we knew and the angle that we wanted to figure out. Then we wrote what that meant in terms of the inverse trigonometric function, and then we used a calculator. So if you had been given the information, let's say this was 7 instead, then the piece or the trigonometric function that ties together what you want to know, theta, what you know, the adjacent and the hypotenuse, is the cosine function. So if I had given you this problem instead, then we would have written cosine of theta is 5/7, and we would have used the inverse cosine function.